Good evening, everyone. So let me share the screen, jump into the subject. Yeah, coming to the FE exam, the first question, you guys can answer this. Is it an open book test or closed book?
It's an open
Close
book.
book test.
Yeah, you're right. This is open book test. So
Okay.
are you allowed to carry the handbook or is it a soft copy?
It's a soft
It's
copy.
soft copy.
Yes, you guys are right. It's a soft copy. Generally, it's a PDF and the PDF, have you guys seen the PDF? How does it look like? I guess you guys might have gone through this. The handbooks looks like this. So like the iPhones get upgraded with versions 8.4, 8.5, so on so. The handbook, this is the FE Reference Handbook that gets upgraded with time to time. The latest version is 10.4. And when you come to see this handbook, the same PDF will be shown in the system during the exam, and these are the contents in the handbook. If you see the contents, there are some subjects irrelevant to civil engineering that are, you can see here, thermodynamics. Thermodynamics comes under which category? Is it civil or mechanical?
Mechanical.
Yeah, thermodynamics is mechanical, heat transfer is mechanical. There are plenty of other subjects as well. You can see the core mechanicals engineering. So the first thing you have to know, this handbook which you get in the exam is the same for all the engineering streams. For chemical, mechanical, civil, and all other whatever streams there are, it is common. And being the civil engineer, it's our duty, it's our purpose to learn which pages are meant for civil engineering, like statics, dynamics. There are some common subjects like maths, ethics, so on so. There are subjects for civil engineering. Next question for you. How many civil engineering subjects are there for FE?
14.
Mm,
13.
yes. So I got three answers out of that. One is perfect, almost correct. It is 14 subjects.
14.
Yes, it is 14. You can see in our webinar, in a free webinar, we have mentioned this. If you want to know much about the FE, you guys will be having the free access to this. You can see this. We have 14 subjects.
And I
So
think all are compulsory. We need to go through all the subjects.
yes, you are right.
But
We need to go.
everything is like a different marking criteria.
Yes, everything will be like different marking criteria. If you go to again, I can resolve your doubt. So we have 14 subjects. Our doubt is whether all of them has equal weightage or different weightage, right?
Yeah.
So when you come to handbook, this is our handbook in the exam. You can go to last few pages. There is syllabus over here. So you can see here, and the last, this for environmental kit, this thing coming to the electrical, no, civil. So you can see the fundamentals of engineering. Civil CBT, that is computer-based test. Here the syllabus. When you come to the syllabus, they have mentioned the 14 subjects. And coming to the weightage, they have given possible number of questions. Like in the math and statics, you'll get around 18 to 12 questions. That is 18 to 12 marks. Okay. So how many total questions we have in the exam? Is it 100 or 90 or 110?
110.
Yeah, you can see here we have 110 questions. So each carry around 1 mark. The weightage for the mark is just one. But coming to the subject wise, some subjects have very less weightage, like 4 to 6 for ethics. And statics have, which we're gonna start now, has 8 to 12 marks, which means on an average you can get around 10 questions or 10 marks. Likewise, our team, we have made an effort to make the pie chart as per the range of the marks. You can see here, some subjects have
Mm.
less weightage and materials. It's a structural subject like introduction of civil materials. It has around 5%. And coming to the subjects like structural engineering, it has 10%, geotechnical has 10%. So each subject has different weightage. We suggest you to give more priority on bigger subjects, and when you get the time, Then go for the smaller subjects like ethics and so on. Anyway, each mark is important for us. Let's prepare for 110 marks. Out of that, whatever may be our toughness of the exam, we will crack it with 70 or 60. And the pass mark varies subject to test to test. It actually works like a normalization. It based on how your friends, how your fellow participants have performed the exam. Excuse me. And we have how many hours for writing the exam? If you remember, is it 2 hours exam or 3, 4, 6?
6.
Yes, you guys are right. We got 6 hours for writing the exam. It's a gross time. In between, it's like morning session and afternoon session with a break between that. If you remove the break of around 25 minutes, actually we have 5 hours, 20 minutes to write actual exam. And if you break this minutes to 110 questions, you'll get around 2 to 3 minutes for each question. So 2 to 3 minutes is pretty, sufficient time, and the level of questions in the exam will be basic. Why? The name itself says it is FE. What is F here?
Foundational engineering.
Fundamentals.
Yes, it is fundamentals of engineering. It's not like pro level, advanced levels of engineering. It's just fundamental. They will ask you some basic questions like what are the ingredients of concrete? You guys know what are the ingredients of concrete? Can you tell me?
Sand,
Yes.
Aggregate,
water,
cement,
aggregate.
Water and
sand,
aggregates and
and
Perfect,
water.
perfect. Water. So, and they will go
Aggregate.
slightly, since we did engineering, they will go slightly ahead of this, and they will say, well, if cement concrete mix ratio is 1:2:4, then what is the quantity of sand if I use 400 kg of concrete? If I want to make 400 kg of concrete, what is the amount of sand I want to do? Then it's very simple, 2 by 7
Divide
into
by
400.
6 and yeah.
Yeah, 7. Actually, summation of
Oh,
1
sorry,
plus 2
divide by
plus.
7 and then yeah.
Yes,
Right.
yes. So this is the exact level of questions you'll get in FE. Don't worry, we'll make the things very easy for you. Going much further, let me go further. Yeah. So I take the subjects, especially the structural subjects, structural related subjects, and out of them, the first thing we do, the first subject is statics, which is a basic subject. Out of from statics, slightly, we can jump into mechanics of materials. It is just like upgraded version of statics. After studying statics, we'll study materials. It's like knowing what is concrete, what is steel, so on so. After studying all the three things, we can jump into what I can say the main hero of the structural subjects, that is structural engineering. And then I'm going to teach the fifth subject, that is dynamics. So this is all about the structural subjects. And I'm going to take one more subject that is related to the water, that is fluid mechanics.
These are the structural subjects.
Yeah, these five are the structural subjects. Apart from these five, I'm going to take one subject that is related to our water, that is fluid mechanics. There is one more subject that is called, hydrology. You guys have heard about this, hydrology or hydraulic system, so on. So it will be taken by one of our teammate. And there are some other subjects like geotechnical engineering, transportation engineering. You guys have pretty well heard about this, construction engineering, so on. So it will be taken by one more friend. Our team is of three guys. The one is Manidhar and Madhav and then me, Vardhan. So you guys might have heard about the last subject of batch 4, that is construction engineering, I guess. Is it the subject or is it economics?
It's engineering economics.
Engineering economics. Okay, that's great. Okay, this is all about introduction. So coming to the subject statics, yeah. So no matter whatever subject you are preparing, prepare as per what, which should we reference?
As per the syllabus.
Perfect. We have to prepare as per the syllabus. So if you see the handbook and you go to the last pages, coming to the statics, the syllabus here is what are the things? Resultant of forces, equivalent forces. So the first two topics are basically about the forces. And then the next topic is about equilibrium. Yeah. And then we study about the frames and trusses. You guys know about what are the trusses, what are the frames. And then the center of area. This is all about the cross-sectional areas, shapes, and then
So
the
this
static
is
frame.
the whole part of the statics you're gonna learn.
Yes, exactly. So this is the entire statics. Is there any in the next page? No. So and how many marks you can expect? Around 10 marks. The very simple subject, we get around 10 marks out of 110 marks, which is nearly 9%, isn't it? So if you clearly, perfectly listen to the class for 5 days or 6 days, based on the requirement, you will get 9% of marks in your pocket. And coming to the rough, I will show you how we're gonna study this subject. If this is, excuse me, if this is statics, we will learn the things step by step, no need to hurry. The first thing we will learn about is the force. The pretty basic thing, the force. And then with the forces, we'll do some components of forces. So can anyone say what are components of forces? What does it mean by components? Just random answers if you want.
Newton, kilonewton.
Mass and
Yes.
acceleration.
Mass and acceleration. Okay, you guys are saying about the force. Yeah, the force is equals to mass into acceleration. You guys are right. And component of force is like if on a
Summation
body.
of Fy.
Yeah, you are almost right. If it is a body, a block, and it has the wheels and it is resting on a free surface, and if you try to push this, suppose you are in Walmart, and you have taken this trolley to carry the goods, then you are pushing with this with your hand in some force, making an angle theta with the horizontal. If you break this force into standard horizontal and vertical directions, then we call this breaking of things is known as components. This is X component and we call it as Y component. And coming to the force, force is nothing but pull or push of a body is nothing but force. So whatever thing, if you are playing a football, kicking the ball with your leg is nothing but you are pushing it. So there you are applying some force. If you're pulling some trolley of luggage in the airport, it's nothing but a force. You're pulling it. Pull or push is simply the force and breaking this force into a components. And then we'll do the resultant of forces. It's like if there are two forces acting on a body, then the combined effect, finding the combined effect is resultant. After knowing about the forces, we'll come to know slightly something called moment. What is moment? Any guess?
Distance. The
Yes. Yeah. Almost right. Moment is again developed from the force itself. So if you apply some force on a body with some distance from the center and make it to rotation, then we call the term as moment. So when you apply some force with some distance from the axis of rotation in order to rotate a body, then this phenomena is known as moment, and mathematically we do it as force into distance. Can you give some practical examples, guys, where you can see moment in day-to-day life? There are plenty. I know you can answer this. Where do
Moving
I
car,
apply moving car?
moving car, or a push,
Mm-hmm.
or a pull,
Mm-hmm.
or
Door.
or
Door.
Perfect. Yeah, that's a very good example, actually, door. So if this is a door frame and this is my door actually, and guys, this door is hinged around this axis. These are the door hinges. And when you try to open the door or close the door, when you see from the top, if this is my axis, if these are the hinges, and if this is my door frame, door shutter, you are trying to rotate this. You're trying to rotate about this hinge, either like this. So there is a rotation with some force here. Here there is a door knob. You are pulling this. So force is here and distance from the door is D. Then we can say it technically. We do apply moment rather than force. There is a force actually, but this force is causing rotation. That's why we can say, since you are students of FE, you are civil engineers, you can say a moment is applied to open the door rather than a force, to be more precise, being a civil engineer. Got it? So this is a very good example of door. That's great. And coming to next thing that we call it as slightly ahead, we go further, we call it as couple. Again, the flow chart continues. Because of force, we got moment, and because of moment, we got couple. Couple and moment are correlated. Can someone name what could be the couple means?
Equal and opposite forces.
Yes, you are almost right. You are 90% right. Equal and opposite forces with
About a
one.
distance.
Yes, about a distance. You are now 100% right. Your good name, please?
Umesh.
Umesh. So our friend Umesh has answered that couple is nothing but two equal and opposite forces, that is F and F here, and they are separated by some distance D. Actually, Umesh, you are 99% right. You missed 1% of answer, that is, and if this combination causes some rotation, then
Okay.
F into D is called as, this F into D is called as couple. So you can notice this, moment or couple are almost same. Both are causing rotation. The only difference is in moment we got only one force. In couple we got two equal and opposite forces. There are plenty of day-to-day life examples where we are applying couple rather than moment. So tell me guys, where have you seen this? I'm saying plenty.
Opening
Like
a bottle cap.
seesaw.
Yeah, one of the answer, opening a bottle cap. If this is my bottle and this is my cap, with the fingers, with the two fingers, you try to rotate this. So there is one force here and the other force here acting in the opposite direction, and you are rotating the cap actually. So there is a couple here. And any other answer, someone says seesaw. You mean seesaw? Perfect. It's a perfect answer. You are saying the kids that the playing in the garden, playground. Are you saying about this?
Yes.
Yes, you are right. One kid is sitting over here, other kid is sitting over here. If this kid moves down, the other kid will moves up about this hinge where there is a
The
rotation
walking,
happen.
walking.
Walking.
Yeah.
So you are saying walking. If a person is walking where there is rotation, can you please explain slightly?
There is a like, mm, yeah, there is a rotation, but we apply the force and the same force in the opposite direction. Is it?
Okay. It's like partially couple. You know, saying when he is walking, one leg will be forward, other leg will be backward, and it's a repetition. Actually, it's not a rotation. It's just an oscillation, to and fro, because of
Oh,
that
okay.
you are moving, right?
Oh, yeah,
So that's
gotcha.
why we call it as couple. And one more example, if you see while
Range.
driving a car, yeah,
We can use range rotating to tight the bolts.
torque wrench. Yes, you are right. Again, if this is my hexagonal bolt, and if you see the range here in the mechanical thing, here there will be force applied, and in the same direction other, I'm trying to rotate it. You are 100% right. That's a good answer. Any more, couple?
Water tap, car steering.
Yes, that's a good answer. Car steering. If your steering wheel and these are the arms, you try to, generally some of us can use one hand itself while doing some work, but this is also kind of couple. So you guys, now you are studying FE practically, so you know the basic difference, force versus moment versus couple. That's pretty good. You guys are smart enough. Catching the things very fast? Going further. So we'll study force, components, resultants, moment, couple, and then we go slightly ahead. Because of these things, these 5 things acting on a body will undergo some motion, isn't it? If you apply some force, here the door is under motion actually. The rotation or translation, that are other thing. If you apply some moment, the body is under motion. If you apply some couple, the steering wheel is under some motion. Anything under motion or which are applied by forces, and but still even at rest, they will be staying at equilibrium. There is some funda called equilibrium of a body. Generally, when a body is at rest, we say this body is in, excuse me guys, we say the body is in equilibrium. I mean to say, now you guys are in Walmart and there is a trolley with these wheels like this, and you are trying to push this. You push with some force with your hand. Will it move or it will not move? You apply some force that is pushing. My question is, will this trolley move
Yep.
or it doesn't
Yes,
move?
Yes.
it will move.
So because of the force, it will move. And suppose there is some other notorious guy in the Walmart and he stands in the opposite directions. He will apply the same force F. Now, will it move or it will just stay at the same position?
If
It
both
will
the
stay
forces are
same.
same equilibrium.
Yes, if both the forces are same, then the body will be in equilibrium. It is at rest. So I can say if a body is under many forces, it need not be one, it under many forces, but the summation of all the forces is 0, then I can say body is in equilibrium. Can I say this?
Yes.
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 Equilibrium is nothing but just remember one lame word, that is rest. If I say the word equilibrium, just simply assume that the body is at rest. So we'll study much more about this. This is about the equilibrium, and then we'll slightly go ahead and study about equilibrium equations. So equilibrium equations are again came from the effect of this equilibrium, where just now I have mentioned you, instead of just one sigma fx, I can write it in 3 directions like sigma fx, summation of all the forces in x direction, summation of all the forces in y direction. And to be frank, if a body is at rest, it is not rotating also. It's not toppling over its body itself. So I can say summation of all the moments, or I can say the word couple also, summation of all the moments or couples are 0. All the 3 equations, we call them as equilibrium equations. We'll learn about them clearly. This class is just like summary. Our preparation should be like work from whole to part. Have you heard this line? To work from whole to part?
No.
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 Some of us might have heard this. Yeah.
In surveying, we will use this term.
Yes, perfectly. In surveying, to reduce the errors, we work from whole to part. It means that if you are surveying a big land of 30 acres, you first measure entire outer length and then break into smaller pieces and then go for the measurements. The same funda applies here. You just learn the whole thing first. You came to know that there are 14 subjects. If I say the word FE, in your brain there will be 14 subjects. From that, your brain will think that in structural I have 5 subjects, in water I have 2 subjects, in there are some other subjects like geotechnical and technical, and you have heard about ethics and mechanics and maths. After coming to this statics, now your brain will go to the list of subtopics. What are the subtopics till now we learned? Can you name them?
Force,
Yeah,
and
perfect.
force,
Perfect.
moment,
Moment.
Moment. couple,
couple,
equilibrium,
equilibrium.
and equilibrium equations.
equations.
Oh, wow, that's so great. That's so great. This is how you should learn a subject so that your brain won't get stressed. So what always it's like a desktop. You go to your folder FE, and then in the folder FE go to the folder statics, and then in the folder statics go for subjects. So your brain should think like an order. That's good. Going further, there are a few more things. So once you learn about these things, then there are our basic things like the beams, and then frames, and then trusses. How they are correlated to the above things? If beams are nothing but they take the loads. The loads are nothing but forces. And in the beams, beams are rested on either support on pillars or abutments or so on. So they are just like supports. On the supports, because of these reactions, there will be reactions developed, and reactions are again, there are forces again. So see, you can see the lunge from here. Beams are again combination of forces. And since the beam, I will say you one thing. If suppose there is a bridge over here, there is a end support, and there is a river flowing like this, and we have constructed some bridge over this through a beam. Assume it's just as it's a timber beam, and the persons who are crossing this in a village over this river, they will be in motion. But tell me, is this beam in motion or it will be at rest?
Motion.
So no,
No,
It's
it will be
rest.
in rest.
Yes.
yes.
It will
Beam
move.
is at rest. The beam will not move along with the along with the guys. It will be there itself, no matter 100 years or 50 years. The beam will be here itself. So we can say the beam is at rest, and we can say we can apply equilibrium equations on the beam. Got it?
Yes.
Yes.
I will ask you one cross question now. It's for all, but because of these guys moving over this beam, these guys might be having 50 kg, 60 kg, 70 kgs. Because of the loads, beams are not rigid bodies. Beams are rigid or they will undergo some bending. Which is right answer?
Bending.
They will go undergo
Bending.
bending.
Perfect. The beam will undergo bending when a person moves like this. The bending will be generally very small. It doesn't, uh, we cannot notice this with the naked eye unless and until we place some, strain gauges, so on so. So this motion from here to here, can I take this as a motion and can I say that this beam is not under equilibrium? Can I say this?
No.
No. Since
No.
you guys are, I made you to think, your thinking is right. This beam, even though it's undergo deformation, the deformation cannot be treated as a motion. So just remember the fact, deformation is just change in shape, but not it's a motion.
Sir, I have a quick question.
Yes, you can. Yeah.
Like there are continuous flow of force on the bridge.
Yeah. Yeah.
What happened then? Then the bending moment is like continuous bending moment, right? Bending moment will be there if the force is on a continuous motion.
Yes. So for this, for your question, you are saying if the load is undergoing continuous motion,
Yeah.
when the load is changing, the stresses the beam undergoes will change.
Yes.
But again, when the load is removed, it will regain its original position. Will it regain or it will remain same?
It will regain.
It will regain. That funda is known as actually elasticity. And so again, it will come back to the rest. It will not be in permanent deformation. Just because many roads are traveling over this road, it doesn't keeps on sagging. We'll design this beam in such a way that whatever the maximum load, you will design for that maximum load. Once that load has crossed, again, it will regain. That we call it as elasticity. And there are some other related topics like influence line diagram. Because of the moving load from one end to other end, the stresses in the beam will varies. The bending moment diagram varies. It will be maximum for particular location of this passenger. For so and so, we have the topic called influence line diagram. We may expect one question, and it is under the subject structural engineering. Where is our flow chart? So in this subject, we'll study much more about your concern, like the moving loads. We call the topic as influence line diagram. Okay,
Got it.
got it. Similarly, once we learn about the beams are just the load taking structures which will take the load through bending, or we call them as flexure. We go slightly ahead, we call
A
them as
quick
frames.
question.
Yeah,
So on the beams, even though there is a slight bending moment, it's still
yes,
considered as equilibrium, right? Because it's
yes,
fixed.
yes, because it's fixed, it's not in motion, continuous motion. We apply equilibrium equations in beams.
Okay.
Okay. So from beams, once you learn about beams, we can slightly jump into frames. Frames are slightly like upgraded version of beams. Can you say what are frames?
Frames are, I guess, precast structure in the like sections.
Yeah, much more. You can make it much better. Any better answer, please?
Column and beam.
Basically,
Column,
combination
yeah.
of beam and columns.
Perfect. Most of you have answered. It's combination of columns
Beams, yeah.
plus beams. So if I go to the notes, I did not start the notes yet, but I will show you. You guys are pretty right answer. Yeah, here you can say the combination of the beams and then the columns, we call this framework is as frames. You can see this frame while doing the stat pro also. In the stat pro, we design a RCC structure as a RCC frame. Like lines, we can represent by lines, and the combination of beams and columns is basically frame. So we'll study some small things about the frames, how to find these reactions, what are the shear force and bending moment in beams and columns in a frame. We can study about them. And after that, after coming to the frames, the third thing that is trusses. Tell me, guys, how are
Ang
trusses? Yeah, different
Angular,
from. Mhm.
angular, they have angles.
That is one of the answer. Yes, one answer is right. How are trusses different from beams and frames?
We can say members joined at ends
Joints.
to form
Truss
a
has
triangle kind of
more joints
things.
than any other frame. What do you?
Perfect. I can hear multiple answers. Your answers are right. One of the answer I heard is members are connected at joints and to form a triangles. That's a pretty good technical answer to be precise. So when you see, uh, this is a beam and these are the supports. When a load is applied, it can be point load. There are different types of load like point load, uniformly distributed load, varying load. This beam undergoes what? Will it undergo tension or it undergo compression or predominantly undergoes bending? Which one will be the failure?
Bending.
What? Yes, predominantly the deformation due to the external load will be by bending. You guys are right. Now, this is all about the beams. Coming to the columns, and suppose if this is my column and this is the foundation or the base, and there is some slab or beam over this, and the load is transferred like this. Tell me which is predominant? Will it be under tension or compression or
Compression.
it?
Compression.
Compression.
Yes, you guys are right. Here it is bending predominant. Here compression is predominant. Always remember, buddies, there will be tension here also, compression also, but they will not be predominant. There will be tension here also and bending also, but they will be not predominant. Each member has its predominant stresses. Here bending stresses, here compression stresses. So you can ask me where there is
So,
tension and yes, please.
yeah, why is that bending for the beam and then compression for the column?
You can directly say this. Seeing the figure, you can
So
answer
the
directly. Yeah.
So the compression is from the top of the beam, and tension is from the bottom of the beam because the beam is stretching. The rebar are trying to retain its original shape. So that's how it
That's
generate tension.
Is it
that's
because
good.
the load is
Mm.
at the center of the beam, right?
But yeah, I will say one answer first. To my question, I asked you one question, why there is tension and compression. Our friend has very well answered because that bottom fiber, since it is bending like this, it has to bend only by stretching the bottom fibers. So in order to stretch it, there is tension on the bottom fibers, especially there is a reinforcement steel. Since concrete is weak in tension, we place a steel here, it undergoes tension. And since there is compression here, you can see if the beam is deforming in the shape, definitely there should be increase in the length in the bottom fiber, and there should be decrease in the length in the top fiber, because you can see the exact change in the deformation looks like this, to be very precise. And you can notice the distance A to B is decreased here and C to D is increased after deformation, and that's why there is compression. So that's why there is compression and tension. But one of our friend has asked a question, why in the column the compression is predominant and why in the beam the bending is predominant? So some of them try to answer. You can proceed answering it now. There is answer right in the figure.
Area of force applied.
Axially
Uh,
from the top.
Perfect. Your good name, please?
Ubaid. Ubaid
Ubaid.
Sharif.
So Ubaid Sharif has answered that if this is my member called column, every member has its axis. This is called the axis of the column. If the load applied, suppose this is my load applied. If the load applied is along or parallel to the axis of a member, then that member will undergo predominantly compression. And similarly, you can see for the beam, the axis is this. This is called the axis of the beam. How is the load applied here? Is it load parallel to axis or perpendicular to the axis?
Perpendicular.
Yes. If the load is applied perpendicular to the axis, the member will undergo predominantly bending rather than compression. Got it?
Yeah, got it.
Now, you guys are smart. Since you are responding very smartly, I will ask you one question. So, when will a member undergo predominantly in tension rather than bending and compression? This is correlated to trusses, I can say. Tell me where you can see in the day-to-day life where it is predominantly under tension rather than under bending and compression.
And it's pulled from both sides.
Yes, that's a simple answer. Instead of the load being it's a compressive load, if you just pull it away, it's gonna be predominantly in tension. Which element in your day-to-day life where it undergoes predominantly tension? For
Like
beams, yeah.
uh beam for gutter where we do pre-tensioning.
Wow, that's very good answer. That's highly technical answer to be precise. If this is a beam, actually beam is designed as a flexural member, but sometimes what we do, we place some tendons here and we try to pull them before even applying the loads. So
Yes.
this is kind of maximum tension. It's like pre-tensioning the member so that it will act against to the compression where it has developed. When you pre-tension it, this tendon will try to regain its original length. Because of that, compression will be developed, and this will nullify whatever the tension that will develop due to external load. That's good. You guys are pretty, uh, smart enough. Coming to the
Yeah,
next
that can
thing.
also be happened in the pre-tension slabs, right?
Yeah, pre-tension slabs also. Slabs. Okay, coming to the element slab. So how is
Sir,
slab? Yes, please.
can you please explain that point once again?
What is the thing? Pre-tensioning.
Tension, yes, pre-tensioning.
Okay. This is topic of pre-stressing of beams, in beams, but not in the syllabus, but you guys are curious. If this is my beam and there is a load, because of the load, you guys know it will deform like this and deform like this. And because of this, there will be tension predominantly in the bottom. Am I right? Is it right first?
Yes.
So this portion will be under tension. Since most of the beams in our construction are concrete, can you guys tell me, is concrete strong in tension or weak in tension?
Weak
Weak
intention.
Weak
intention.
intention.
Concrete is weak in tension. Because of that, there will be cracks, form tensile cracks, which looks like this. And because of cracks, corrosion happens, so on. So again, the topic diverts, no worries. So concrete is weak in tension. So one of our ancestors think the good thing is they added reinforcement steel in the bottom. That's why in predominantly you can see in the day-to-day life, this reinforcement steel is at the bottom so that the entire tensile load will be taken in the steel. But still with the increasing population, with increasing constructions, the loads are keep on increasing and increasing. And this steel alone is not enough to take these tensile loads. Then people getting smarter and smarter with the generations, what they did, they pulled this steel using some hydraulic jacks or whatever may be the procedure, heating also one of the procedure, they will pull this. Now think of your brains, just replace this steel and assume it as a rubber band, which you see in day-to-day life. Steel itself is like an elastic material. It's like a very strong rubber band. So you can replace it by rubber band. So yeah, this is a beam again. These are the supports again. Make a hole here, drill a hole, or while casting the concrete, keep a pipe, PVC pipe, make a hole. Place this rubber band in this. Initially, its length was so and so meter. Suppose it is 2 meter, take the rubber band of this thing, 2 meter with some lengths to pull. Now pull this rubber band and then pull it like this and then freeze this rubber band now. When you freeze this here with some jacks, anchors or whatever maybe, when you freeze it now, this rubber band is now in a stretched state, right? It is under stretching now, isn't it?
Yes.
So since it is in stretched state, because of its natural elasticity, will it try to get back its position or not?
Yes.
So since it tries to get back to its original length, it tries to apply some compressive force on this ends. Will it apply or not? It trying to pull it back its length. So in that process, it tries to pull this together towards
Yeah.
each other, right?
Mm.
Yes.
Because of that, we have induced an artificial compression here. This artificial compression will nullify the tension that has developed due to a given applied load, isn't it? Even though there is 100 Newton per mm square of tension because of external load, because of pre-stressing, this can be due to 50. This compression might be 50 Newton per mm square because of this rubber band. The net tension gonna become 50 Newton per mm square only. We are reducing the tension that has developed by nullifying with help of pre-stretching the rubber band. Got it? This is the basic fundamental is very simple behind the pre-stressed concrete. Clear?
Yes, sir.
Yes, sir.
Okay. It's not there in syllabus, but getting the knowledge is always good for our career. Yeah. So coming to the trusses, guys, how are trusses different from beams, frames, and columns? Now we have 5 more minutes, and this is a support. The trusses looks like this. Trusses are all straight members, and each and every truss are connected by some joints. These are the joints. And you guys might have seen many truss bridges. Name some bridges, truss bridges in your day-to-day life. In US, have you seen any bridges like this?
Every second bridge is say truss here.
Yeah, okay. Truss here. When a car moves like this, the trusses are again many types. Like it can be duct through trusses, duct trusses, etc. Most of them looks like this. Car keeps on moving like this. The main difference between the beams and trusses or frames and trusses are, in the beams or the frames, basically, frames are nothing but beams and columns. The members, if this is my frame, the deformation gonna be like this. The bending will be happening in the beams, there will be compression and slight bending again. The bending is there. You can see the members undergo primary or secondary bendings in frames or in beams or in columns. But coming to the trusses, the main difference is no member in the truss undergoes bending.
Yes.
They will not undergo any bending. They will undergo either tension or they will undergo compression. There are only axial forces. That means the tension or compression in the members. And there will be no bending. If at all there is a bending in the truss, it means that someone has designed it wrong. There are some eccentricities in the connections, so and so, because of secondary moments, and because of that bendings are possible. Ideally, theoretically, as per the book, as per for the exam, always remember the members of trusses do not undergo any bending. They will take only axial load. And one more important thing is all the joints of the members are pinned joints. What are pinned joints or hinges?
Point that helps in distributing load or equally distributing loads.
Yes.
Attached in all positions.
First answer that helps in distributing the loads is the right answer. That is 50% right answer. What are these pinned joints or hinges in the trusses? You have to add some other 50% of answer. Can you add someone else?
Only two forces, right?
Only two forces, that are Fx and Fy, but not moment. You guys are saying ahead. In lame words, I can say these pins are like free hinges. Like in the door, you can freely rotate the door from here to here about this hinge. You can freely rotate these members about these hinges. The hinges have freedom of rotation.
Allows rotation.
Yeah, there will be no restriction to rotation. They will be connected in such a way that they will be free to rotate. And because of that, there will be no moment reaction developed, and there are reactions only Fx and Fy. We'll see that clearly. This is all about the trusses, and after that, we'll study the final thing, areas. Either it is a beam, it has some shape, some cross-sectional shape. Either it is in rectangle. In day-to-day life, you might have seen I-shaped steel beams and hollow beams, hollow sections. We call them rectangular hollow sections, so on. So even the trusses, you can say circular hollow sections or circular rectangular hollow sections, so on. So these are the different shapes of members we can see for beams or columns or trusses. So because of that, there is some new topic that has derived from these three, that is areas or different shapes. On these shapes, there are mainly we study about finding the areas of these shapes, or there is a one predominant term called moment of inertias. We'll study about them, and then we'll study about radius of gyration with some examples that will be over. And then the 12th topic is friction. The friction is a thing. So what is friction? You guys know it very well.
Static energy caused due to rubbing.
Yes. So
Opposite force.
yeah, the friction acts between two bodies which are in contact, and that friction acts along this contact surface, and friction will generate when there is motion between these two bodies in the opposite direction. If the two blocks are moving in the same direction, there will not be friction. When you try to rub two bodies against each other, then friction will develop. And because of this friction, there will be heat developed. That is, we do rubbing of our palms in winter, this kind of frictional energy converting into heat energy. So in the subject statics, we'll study this dozen of topics. With that, the 10 marks will be out of 10 marks, out of 110 marks will be in your pocket. So that's it, end of the session. From tomorrow's session, we'll study the things in detail. Okay. In the tomorrow session, we'll study this force and couple. In the day after tomorrow, we'll study this, equilibrium and equilibrium equations and some beams. And then in the third session, we study the trusses. And then in the fourth session, we study these 4 topics. So today is the first session. We are left with 4 more sessions. With the 5 days, we will complete this topic. Clear? I'll do my best to make the things clear for you.